In 1975, a British economist named Charles Goodhart formulated an idea that is very emblematic of basically all systemic failures in modern software engineering. That idea was called Goodhart's law, and it simply states that any metric that is a target in and of itself ceases to be a good metric. Because look at the modern engineering dashboards in any corporate environment. What do you see? You see a sea of green labels, green text, and green reports, green squares everywhere. Because everyone is rejoiced that we have 90% code coverage, we have 100% pass rate of our tests, we have this great velocity on the burn down chart, and we have so many Jira tickets closed per sprint. So all those metrics look really healthy, right? They look like the engineering process is going very well. However, the actual software being the result of this process very often turns out to be a fragile pile of hot mess, basically, something that crumbles the very second an actual user tries to interact with it. And that's because we have built an industry that is in love with measuring all the wrong things. And in this video, I'm going to try and take a closer look at all these vanity metrics, what's actually in store for us, how the teams try to game this system, and what can we do about all of this, if anything. Let's start with the most abused metric in testing, and that is code coverage. The story probably goes something like this. An executive read some time ago in some kind of an article or a blog post reading that the higher the test coverage, the better it gets, because the higher the probability of catching the defects early. And so they decided to mandate a rule for the whole team or the whole organization that we are striving to hit 100% code coverage, or we simply outright block any pull request that does not contain like 90% of code coverage. However, when we take a look one step further, what does actually happen to the engineers when they know they need to hit an arbitrary target of code coverage? The thing that inevitably happens is that they don't write tests to validate business behaviors, but instead just write tests to run lines of code. I have myself seen code bases with 95% code coverage, with the unit tests having 0 assertions. They simply run the code, catch any exception, and finish. So the code executes, the tests turn green, the metric is passed, the pull request is merged, and absolutely nothing of any value has been proven in that whole process. And the exact same phenomenon happens with test suite pass rates. Because when the management requires 100% pass rate for a deployment to happen, the engineers adapt. If an end-to-end test in Playwright or Selenium is flaky because of some backend problems, what's the easiest way to have it be green? It's just to skip it, to quarantine it, to comment out the flaky line, the flaky assertion, or to just swallow the error. The metric turns green, the release goes out, and the bug lands in the face of the end user. And this kind of gaming of the metrics isn't isolated to the engineering work, because it has corrupted the whole agile process through story points and velocity. Because when a team's performance is evaluated by the number of story points they burned through or the number of tickets they have closed in Jira, it stops being an engineering endeavor and becomes kind of an assembly line. Developers are incentivized to break elegant stories into 4 artificial smaller ones just to inflate their point count. At the same time, they are discouraged from spending time on stuff like refactoring ugly legacy code, improving documentation, or mentoring junior engineers, because even though each of these tasks is really high value, it has a low story point content, so why bother? If a developer spends 3 days hunting down a kind of niche exotic problem, some kind of a architectural bottleneck that actually prevents failures in the future and helps us for the future, their velocity may look terrible on paper. But if they spend these same 3 days slapping some kind of hot fixes on 5 different Jira tickets, they look like a rock star to the management. We are rewarding short-term metric hunting while at the same time punishing long-term engineering health. And another dangerous target is the zero defect leakage rate. The idea that no bugs found in production should have ever escaped QA. And while the intention does sound noble, the reality of it is that creating a key point indicator out of a thing like defect leakage rate creates a culture of fear and dishonesty. Because when QA teams are being penalized for bugs escaping to production, they start playing very defensively, too defensively, to actually provide the value that they could provide. Instead of working collaboratively with developers to find solutions to the problems, hours are being spent discussing and arguing in the comment sections, on Slack messages, over email, on the meetings, on things like ticket classification. Because is this issue a defect or a change request? Because if it's logged as a defect, it ruins the QA metrics. And if it's logged as an enhancement, the metric stays clean. And meanwhile, the ones that are suffering from all of this are the actual end users who are just getting a worse product because of two internal teams or sub-teams effectively exchanging like arrows back and forth and just constantly arguing about internal vocabulary in order to meet the metrics they are expected to meet. When metrics drive behaviors, truth tends to be the first casualty. And so how do we escape this trap? How do we do all of this without destroying the culture and also without destroying the product? First, we need to abandon vanity metrics and focus on operational outcomes. Stop caring about raw code coverage percentages and instead start looking at change failure rate, for example. How often do deployments actually break production? Stop measuring how many test scripts were executed and start measuring mean time to recovery. When something inevitably breaks, how quickly can the team detect it, isolate it, and fix it? Tools like DORA metrics, the DevOps research and assessment, actually focus on system velocity and stability rather than just counting line executions. Secondly, treat metrics as diagnostic tools rather than performance indicators. Code coverage, for example, is useful for an engineer to find untested paths in a given module. However, the moment you turn that into a corporate key performance indicator or a target, Goodhart's law takes the wheel and corrupts the signal immediately. And finally, none of what I mentioned actually matters in the long run if we fail to build a culture of psychological safety. High-performing engineering teams don't hide the failing tests and don't try to game the system of counting lines or test scripts or test executions. They treat a failing test as a valuable feedback and a production bug as a learning opportunity to draw something from and to improve their release process for the future. So yes, metrics are very important. We have to have something to lean on, but prematurely or naively falling in love with many of those metrics and trying to draw not only conclusions, but maybe some kind of definitive judgments from all of them is road to nowhere. A green dashboard on Jira or a green CI pipeline does not mean you have a good project on your hands. It just means your team figured out the rules of the game and are getting very proficient at gaming it. Because real quality isn't built on spreadsheets, it's built on shared ownership, pragmatic risk assessment, and focusing on delivering business value and delivering user value over administrative metrics. And I'm curious to hear from you, what is the most absurd kind of a metric that you have come across in your career, in your projects? And also, what's the most heavily gained metric you had to deal with? Let me know in the comments down below, and please remember to like and subscribe if you want to get more of these kind of honest discussions on software engineering reality. And until the next episode, just remember to keep on rocking.